do the design? There are 4 parameters to design. Last class I have told you that how to calculate. What do you mean by design is not drawing. What is the size of each component? That is called design. 4 components are there. Design procedure of rooftop rainwater harvesting system. There are 4 components you have to design. First component is called gutter. I have told you that there is a catchment area. This area will be flattered. The sloped area will be flattered and it will be taken as a rectangle. I have told you in last class, no? You have to take the length and breadth. Next parameter is designing this gutter. That you mean by you will be having a small slope. From the rainfall, it will fall into the gutter, then it will flow into the pipe. Second component is called a pipe. Then third component is called a filter. Fourth component is called storage tank. So if you want to install a rainwater harvesting, there are 4 components. Indian standards has given guideline for all the 4 components. Now let me discuss one by one. First is design of gutter. For each and every component you have to do, it is only available in code book. What do you mean by gutter is, this component is called a gutter. Now how to design is, this is used to collect the rainwater. Soon as the rainfall is there in roof, it will be collected to the pipe, it will go. This edge should not be flat, it should be rounded. Sir, what are the materials this gutter can have? There are few more materials. What are they? Galvanized iron sheet, GI sheet, to reduce corrosion. They are particularly using iron sheet. What it will happen? It will corrode. If rainfall is there, if rain is contacted with the steel or iron, it will get corrode. Why they are doing galvanizing is to reduce corrosion. Next is aluminium sheet. Instead of this, they can use aluminium sheet. Semicircular gutters of PVC. What do you mean by PVC? Polyvinyl chloride, which is nothing but a plastic. They can use plastic as gutter. Last thing is bamboo. Sir, I am living in a forest. I am living in a place where I don't have any purchase material. You can use bamboo. Whatever the rainfall capacity is there, you have to increase 10 to 15% of gutter and you should design. Given in a table. You don't need to calculate anything. If there is a gutter, you have width and depth. Sir, how much should be the width? How much should be the depth is given here. Now can you see diameter of gutter, width of GI sheet. Now in this column you can see rooftop area. Last class I have told you how to find the rooftop area. Length into breadth. For this classroom you have to multiply the length and breadth. So what is the length? This is 3 meter, 3 meter, 3 meter. So totally 9 meter. Now what is this breadth is? 8 meter is this one. We have already measured. That is why I am saying. So 9 into 8 is how much? 72. So for your class, you have to take rooftop area as 72. Do you have 70 here? Do you understand how to design? You have to measure the area and take the 70 to 80 you have. Whichever is higher you take it. 72 is there, hence you take 80. They have given D and W. Sir, what is D and W is? This is D. D is called diameter, W is called width. How much you should provide, they have given here. Example, if you are taking 40, your width and depth, how much you should take is given here. Rainfall in Bangalore is 890 mm. Is 890 mm of rainfall falling in one day? It is throughout the year. No, you should not design for throughout the year. You should design per hour. Can you find here? Sir, you have told Bangalore is 890 mm, but there is no 890 there in the code book. Do you see? They are starting from 10 to 100 only. You should understand mm per hour. This is per hour. This is the way to design the gutter. First thing is over. Second thing is design of this pipe. Sir, how much mm of pipe we should lay? The same way the code book gives a guideline. This tabular column. The size of rainwater pipe, diameter, what you should use is diameter of the pipe, where you have the table here. Rooftop area in square meter, average rate of rainfall in millimeter per hour. For designing, you should take everything in terms of millimeter per hour. For calculating millimeter per year. Do you understand the difference? So, if you are finding per hour, so whatever might be, imagine you have 75. millimeter per hour, you have to take the dia of pipe of 50. 50, what is that? 50 mm. So, second thing is over. So, what is the third thing is there? Filter. Can you see here? Third thing is what? Filter. Sir, why we want to filter? Just like that we can store in the any container or the tank. Why we need filter is the rainwater will be having dust. When it is falling in the roof, it will collect the dust. It will collect the chemicals. So this is called filter. So now third thing is called filter. Sir, what are the types of filter you can provide? There are two types of filter. One is sand filter and another one is charcoal filter. Now, this filter is generally used to remove suspended pollutant. What are suspended pollutant is? It might be some dirts, debris, etc. These things will be removed by using the following material. What are the material? Fiber, coarse sand and gravel. These three material will be there. This image will give you a good idea. Sir, how the filter should be? Rainwater filter should have only three materials. What are they? It will be having a sandwich. Sandwich, inside you have some vegetables or cheese. Top and bottom you have burger. The same way, top and bottom you have this kind of gravel. Gravel or coarse stones, higher diameter. You should have gravel at top and bottom. At the sandwich part you should have sand. This is the way to filter. What will happen if the rainfall is directly falling in this place? It will get filtered and it will go to the tank. Sir, if I am using that, what are the things I can remove? I can remove turbidity. I can remove the color. I can remove microorganisms. Sir, it might have any bacteria. If you are using this filter, that bacteria will get filtered. That dirt particles, turbid will get filtered. These three things will be there. Now, there is a second media to filter. What is that? Is called charcoal filter. Have you heard about charcoal? If you have any odor in the water, if you filter it through the charcoal, after the charcoal, when the water is coming, it will be very pure. It removes all the stains. Sir, it looks like complicated, but it is very simple. In sand filter, what are the things you have used? 2 layers of gravel, center you have sand. Instead of this, you are adding one material called charcoal. Do you understand here? Sir, the same thing, whatever we are using in sand, we are using. Only one material is charcoal we are laying for 10 centimeter. This is the cross section and gravel should be used for 25, sand is 25 and top layer is sand. This removes what? Chemical and improve taste. You can even drink the water. If you are using charcoal only, you should drink the water. Somebody will have a question that, sir, shall we drink the rainwater? Without filtering, you should not drink. Sir, then what filter should I use? Use this charcoal filter. In your house, if you have this filter, you can directly drink the rainwater. There is no issue on that. Now, finally, sir, we don't have a storage tank. We are just letting into the ground. That means, what are the way you can recharge the ground? Is first design of storage unit. Sir, we can store it in a tank. Sir, for houses, it should be stored in a recharge pit. Sir, what should be the roof area? 100 square meter. If your roof area is 100 square meter, you can use recharge pit. For our class, can we use recharge pit? Less than 100, we can use recharge pit. What is our class area? 72 square meter. So, if adopted for buildings having up to 100 square meter. What do you mean by recharge pit? Is again nothing but there is a layer of 3 materials. Boulders. Boulders is meant by large size stone is called boulders. When you are laying a road, you might see the boulder. They will lay large stones at the bottom, which is called boulder. Next thing is gravel. Above that you have sand for 0.8 to 1, 0.5 to 0.7, 4 to 0.6. This size they will be having. The water will be sent here. Sir, from where this water is coming? The water is coming from sand filter. After sand filter, it has to reach here. Then it will automatically penetrate. Sir, what should be the size of this pit? This size can be 1 to 2 meter wide and 2 to 3 meter deep. 1 to 2 meter is width. What should be the depth? 2 to 3 meter. This is the way to do recharge pit. Sir, I am not living in a house. I am living in an apartment. Large area. Now what is the area? Abundant pump you can use. If you are living in an area up to 150 square meter, larger than this, then you can use abundant well. Can you see a hand pump here? Can you see a hand pump? Wherever you have hand pump, you can collect the water and send it to the hand pump here. By using a 100 mm dia pipe, if you are collecting here, directly this hand pump will get water immediately. You can take the water and you can consume. This is the way the rooftop can be fed into a hand pump. How many of them nearby your house you have hand pump? We will take water. There are few students told when submitting the assignment, they told that they have a well. So when they are collecting, if they have a well, what you can do is, after this filtration recharge unit, you can take it to the well. Can you see here? The water can be directly sent into the well. That well water you can consume. If you are having building more than 100 square meter, then you can connect it into a well. The same parameters you can use for filtering. Then next one is trenches. What do you mean by trenches? Sir, my area is greater than 200 to 300 square meter. Larger area, then you can use this kind of trenches. Sir, what do you mean by trenches? Is nothing but 0.5 to 1 meter wide, and what is the length? 10 to 20 meter and 1.5 meter deep. It will be a much wider thing when you are using is called a trench. Your house, you will be having a bore well. What you can do is, after your rainwater collection, you can send the water to your bore well. This is a bore well. Sir, we are taking water from the bore well in the sense, you connect a 100 mm pipe through this kind of a filter unit, then you can directly let into your bore wells. So this can be used for impervious soil. Sir, I don't have any sandy soil nearby my house. You can use this kind of impervious soil. Then you can take the same groundwater into the ground level. Then you can use it 150 to 300 mm dia. This is 150 to 300 and 3.5 mm deep. What are the materials? This is nothing but boulder, gravel, sand. The same way. You check all the diagrams will be having same thing. See, there is a boulder, gravel, sand. All the drawing have same phenomena. The size is different. Design a rainwater harvesting system for drinking purpose during dry days. This rainwater harvesting system is being constructed in Chennai for the following given data. Chennai peak hourly rainfall is 100 mm based on 25-year frequency. When we are starting the rainwater harvesting design, we should take a 25-year rainfall during each and every year. What is the rainfall occurred in each day, and what is the peak of rainfall during any rainy season? There might be peak of rainfall. In a particular day, you might get in Indian Meteorological Department, and there is a peak rainfall concept. In 1 hour, how much mm of rainfall in that district or place? This has to be taken. This is available in Indian Meteorological website for a particular district, and you can take the maximum of that 100 mm per hour. Now this is required for design. While calculating only the storage capacity, last class I have discussed that mm of rainfall per year is sufficient, but now for designing you need per hour, and runoff coefficient is given as 0.85. By this we can understand that it is a roof. The roof area is 200 square meter. Average annual rainfall is 1290 mm is taken here. The monthly consumption of water is assumed as 2000 liters, assuming 5% they are using only for domestic purpose. Around 133 to 135 liters per capita per day they are using, in the sense their monthly consumption is around 20,000 liters. Now, assuming for drinking purpose only, they are using 8 liters per capita per day. These 5 people, how much storage is essential? This is case 1. No, they are using for domestic purpose. What are domestic purpose? Are cooking, washing and drinking purpose. For these things, if they are using this, they can use 135 liter per capita per day. Now, according to this, our storage differs. That we will design for both the cases. Now, there is a tabular column here which gives month of rainfall. Starts from July, August, September, October, November. Here you can see the maximum amount of rainfall, and during January, February, March, April, May, June, you have normal range of rainfall. This is monthly rainfall statistics. This is an average monthly rainfall for 25 years frequency. So why this is required in the sense, we will not get the rainfall throughout the whole year. We will not get a constant rainfall throughout the month. So wherever there is shortage of rainfall, in those days you need rainwater harvesting, that water tank requirement. So let us understand and start designing. Now, the design of rainwater harvesting system, how much of water we receive through this rainfall. In Chennai is, if the area of catchment have given 200 square meter, the annual average rainfall is 1290 and runoff coefficient also they have given as 0.85. Now first let us calculate how much of water is being received through the rainfall. To calculate V is volume, ARC, area of the roof, is the rainfall, annual rainfall and runoff coefficient. So how much water we are getting is 219.3 cubic meter or 2,19,300 liters of water we are getting through this rainwater harvesting system. We can collect this much amount of water. Now this is not month, this is throughout the year. You constantly collecting the water and storing it in a single container. Now first one is design of gutter. For this, gutter is a component where we know that here the rainfall is going to fall in the roof. We are going to collect in this gutter. So this is a first component of design. There are 4 main components: gutter, pipe, filter and storage phenomena for rooftop rainwater harvesting system. In the code book, you can take table 3, the diameter of gutter, width of GI sheet. They have given here as explained in the design procedure. Here our maximum rainfall intensity per hour is 100 per hour. So this we have to take, and the rooftop area is 200. So if you take this, the x and y parameter, you can design the diameter and width of gutter. Diameter is 144 and width is 246 is required. So this is 144 and 246 This material can be of GI sheet, PVC or bamboo, etc. For this width and this depth is essential for this place. According to the rainfall, it is going to change. Here you can see if the roof is very small, 10 meter square of area, you can see 47 is the diameter and 93 is the width. If the area is more higher, you can see the gutter also should increase in order to have the capacity. For this reason, we are taking of rainfall per hour. Now second thing is design of pipe. So we have designed the size of the gutter. Now the pipe, how much dia of pipe is required? This is given in table 2.1 from National Building Code 2016. This is available, and throughout India you can use this. Diameter of pipe should be around 150. How we got that? Roof area in square meter. So what is our roof area? Is 200 meter square. For average rate of rainfall per hour. What is our average rate of rainfall? Is around 100 mm. So nearby that you can take it. You can take around 115.74. In case if there is any higher intensity of rainfall, it might be. So you can take a safer side for. So you can take 115.74 as average rainfall per hour. So for this case, you will be getting 150 mm dia of pipe. So this pipe should be 150 mm dia. So you can lay this pipe and there is an elbow. You can take it to the filter. So next design is called filter. So like this, you have to connect through the gutter. Take it to the ground. Now design of filter. What kind of filter you can install? Currently in recent days we have this kind of filter which is readily available in commercial websites like Amazon, Flipkart and other shopping websites. From the pipe you can have a connection here. You can see all the rainwater is collected from the gutter through the pipe. It is getting filtered and it is being taken into a storage tank. This is one phenomena where in latest technology they can use. Or else if you are taking the water for recharge, groundwater recharge, if you are taking it for storage purpose and using for your household and domestic purpose, you can install this kind of a filter. If you are using it for groundwater filter, you can use a sand filter. This I have already discussed, that laying gravel in 2 layer of sandwich. In between that you can have sand layer of 30 centimeter. From this pipe it will be directly letted into this kind of filter layer. From this pervious bed it will be percolating inside to the groundwater. This removes turbidity and color microorganisms. It will get filtered. Now fourth component is design of storage tank. Sir, if I am designing for drinking water purpose only, this is what is given in the data. I am using 8 liters per day. Imagine now for 5 number of person, how much liter of water can be stored in order to match the demand. If we are looking into that, let us take 5 months of monsoon, June, July, August, September, October. These 5 months you can take, and the rest of the days are dry days. If you are calculating, the 7 months will be having 215 dry days. How much water can be stored for a drinking water requirement? In this case, we have taken as 8 liters per person. 5 number of persons are there, 215 days are there. If that in the case, we need 8,600 liters of water during this dry days only for drinking purpose. And if we are keeping 20% of water for safety, if you add another 20% of liters, it will come around 10,320 liters. Like this kind of 10,000 liters tank you can store. After the filter, you can take it into a pipe and you can store. During the dry days, this water can be used for a drinking purpose. Now I am using it for domestic purpose. If that in the case, what you can do is you can calculate the storage tank capacity. Now for domestic purpose we need 135 liters per day. Let us do this calculation. Rainfall harvested in liters. Now we know that these two are the given data. In July the average monthly rainfall is 98 mm. So how much rain we will get is ARC. What do you mean by ARC? A is rooftop area is 200, and if you multiply by 1 mm of rainfall for each and every mm rainfall, if you are calculating, you can calculate. Or for the month of July, 98 mm rainfall is there. So 200 into 98 into 0.85 is runoff coefficient. If you multiply, you will be getting 16,660 liters of water you will collect. During the August month, you have to multiply 200 into 136. So during this month into 0.85, you will be getting 23,120 liters. Like the way you can multiply for all the month, and you will be getting the rainwater harvested in terms of liters. So finally, how much liter of water you will get. In the sense, you can add cumulatively all the values you can add. This is month wise split up. Now, what is cumulative harvested rainfall is during the July month you will be having the same 16,660 liters of water. In August, 16,660 plus 23,120 liters. So cumulatively it will be 39,780 liters. Then again in September months you will be getting 20,740 liters. So you can cumulatively add, it will be 60,000 liters. Like the way you are adding each and every month, finally you will be getting 2,19,300 liters of water. Now our demand is, monthly demand is 20,000 liters. Imagine we are consuming 20,000 liters per day for that family. The rainfall gives 16,660 liters of water. There is a shortage of around 4,000 approximately. Like that, what is the monthly demand is 20,000 liters for all the month. So this is cumulative monthly demand. Now their demand for this family is 2,40,000 liters is their demand. Now what is the difference here is, this is cumulative demand and this is rainfall what we are getting. So there is a shortage of 3,340 liters in the month of July. In the August, the same way you can find the difference between these two. You will be getting minus 220 liters is the shortage. Like that, you can find the shortage for every month. The rainwater you can use it. After the rainfall, you can use that water. At which month you are getting highest rainwater storage is during the month of December. You can see here. For all the month we have calculated. During the month of December, we are getting 72,610 liters of water. So this is the highest storage capacity required. So if you have this kind of storage, you can use this water during any month. So no need to install 2,19,300 liter of storage capacity. You can only install 72,610 liters of capacity, because you will be using that water monthly for your domestic purpose. The cumulative demand maximum in the month of December, that is 72,610 liters. For each and every 1 mm rainfall, how much liter you will get is 170 liters in Chennai. Around 73,000 liters of water you can store for domestic purpose. I am not using only for drinking purpose, I am using it for domestic purpose. And what is the volume of water you will be collecting is 73 meter cube of water. This is a storage tank which carries 75,000 liters of water. This kind of storage and use it for domestic purpose. Throughout the year it will be useful. Like this, you can design for your own district. This is taken for Chennai. You can take the district wise, and these values are given in Indian Meteorological website. So throughout 25 years, average rainfall is there per hour. Mm of rainfall per hour is there. You can calculate for your area and design the complete rainwater harvesting system.